Welcome dear students once again. We are learning about the techniques which are used to calculate some of the circular motion problems, angular velocity, angular acceleration, and moment of inertia. Here it is. What is the kinetic energy of a 5 kg solid ball uh, whose diameter is 15 centimeter? From this diameter, we will calculate the radius. And it rolls across the level surface with a speed of 2 meters per second square. So here is the speed. After putting values, after putting values you have calculated the speed, and speed relation is v is equal to r omega. Angular velocity is basically calculated by this formula, that is v over r, and you know that during any type of the motion the total amount of kinetic energy will be equal to the sum of the both types of the energies, that is kinetic energy of translation and kinetic energy of rotation. And after putting the values in this formula, if you look at, you have calculated by using this relation, you have calculated the kinetic energy, because you have velocity and you have mass as well. You will put the value of the velocity and you will put the value of the mass in this formula. Then you will be calculating after putting the values in this formula. So here is the main problem for today. A cylinder of 50 centimeter diameter at the top of an incline 29.4 centimeter. This is a question of this class. So, and 10-meter long is released and rolled down the incline plane. Find its linear and angular speed at the bottom, neglecting the air friction. First of all, we will convert it diameter into um, radius, and then the height is given, and this height is given in meters. So linear speed and angular speed, these are the two tasks which you are given to calculate. So here it is. This was the question. Here is the radius calculated. You have calculated the height. You were asked to calculate the speed, and you were also calculate angular to angular speeds. And then this is the formula. Loss in, because you are rolling from a height, and at height it is potential energy. That is equal to gain in kinetic energy. But loss in potential energy is mgh. This was the amount of energy. It is lost in linear type of the kinetic energy and rotational type of the kinetic energy. Rotational energy is this one formula, and translational is this. Then the total amount of this potential energy is converted into translational and rotational energy. So this is the formula to calculate moment of inertia of a cylinder. I is equal to m half mr square. This is the formula to calculate velocity, angular velocity, and after putting the values in this formula, we are getting energy which is 14 joule, 14 joule. So this was the requirement to calculate. After this, you have calculated kinetic energy, and then you are asked to calculate linear speed and angular speed. So here it is. After putting the values mgh, this m is cancelled with this one, and after cancellation you are getting this relation. So gh, that is equal to 3v square, and after putting the values of the quantities given in the problem, you are getting speed, linear speed, by using this formula. And then you are calculating angular relation of linear speed with angular speed, and from this formula you can calculate, if you know the linear velocity, this one, if you know the radius of the circular path, then you can calculate the angular velocity. First you have calculated by using this relation total amount of potential energy, that is converted into linear types of the energy and rotational type of kinetic energy, because the cylinder is rotating and it is moving straight as well. So this amount of potential energy is converted into two parts of the energy. So after putting values, you have calculated the speed. And by using this linear speed, you have calculated angular speed by using this relation. Thank you very much for your patience.